The recent unveiling of the Tesla Cybertruck, one of the most anticipated releases in the electric vehicle sector, has been generating a lot of buzz. However, there's another exciting advancement beyond the introduction of Tesla's futuristic truck. Elon Musk has announced the launch of the Tesla Cybercell, a new generation of innovative batteries. This groundbreaking battery represents a milestone in electric vehicle technology. It promises to far exceed the capabilities of the current Tesla 4680 batteries, known for their performance and energy efficiency. With the Tesla Cybercell, there's an expectation to raise the bar for vehicle range, durability, and efficiency, underscoring Tesla's commitment to sustainable mobility advances. But why the pursuit of a new battery? And what exactly is the Tesla Cybercell technology? Tesla Cybercell, an evolution. Introduced in 2020 by Elon Musk, the 4680 battery underwent significant modifications. Its original design featured a nickel-manganese cathode and a graphite and silicon anode. Unfortunately, the final version saw the addition of cobalt and the removal of silicon from the anode. These technical adjustments led to higher costs and reduced performance. The price increase was a critical factor for the limited use of this battery in Tesla vehicles. It stored about 81.2 watt-hours of energy, with an energy density of 229 watts per kilogram. Compared to the Panasonic 2170 batteries, which had an energy density of 262 watts per kilogram, the 4680 saw a 13% reduction in density. This resulted in slower charging and reduced range, disappointing customers. Consequently, production was halted after the first batch at the Gigafactory Texas. This will be an evolution, maintaining the dimensions of 46 by 80 millimeters, but with technological advancements. According to Andrew Baglino, Tesla's Senior Vice President of Powertrain and Energy Engineering, the Cybercell will have about 10% more energy density than the 4680. This results in an energy density of 252 watts per kilogram, a significant improvement without altering the battery chemistry. Its compatibility with vehicles designed for the 4680 is an additional advantage. Technically, the Cybercell is the second generation of the 4680, but with improvements. While this may seem a modest advance, it indicates that Tesla is ready to launch the Cybercells, maintaining production methods and dimensions. The question remains, where will these innovative batteries be initially used? Challenges of the Cybercell battery. Tesla plans to debut the Cybercell in the upcoming Tesla Cybertruck, hence its name. The estimated weight of the Cybertruck is over 3,600 kilograms, necessitating improvements in the batteries. To supply the batteries for the Cybertruck, Tesla accelerated the production of Cybercell batteries. Starting in January 2023, they manufactured 10 million units from January to June at the Gigafactory Texas. Then, in just 4 months, they produced another 10 million, having the production time. They aim to reach 30 million in less time. However, there are challenges. The efficiency of the Cybercell does not match that of the Panasonic 2170 batteries. The 4680 had an energy density of 229 watts per kilogram, while the Cybercell has about 252 watts per kilogram. The Panasonic 2170 surpasses with 262 watts per kilogram. The 2170 batteries outperform the Cybercell in performance. Due to its weight and the expected torque of the Cybertruck, the 2170s are still the better choice. If Tesla adopts the Cybercell, the Cybertruck's range could decrease due to the various functions required. Although the Cybercell batteries are impressive, their efficiency and performance still do not surpass the Panasonic 2170, making Tesla's choice a challenge. Obstacles and outlooks. Initially, the long-range Cybertruck's estimated range would reach 500 kilometers, something nearly impossible, making the truck even heavier. The 300-kilometer variant would face challenges, needing at least 130 kilowatt-hours of battery to reach this mark. To achieve 300 real kilometers, 150 kilowatt-hours would be needed, 50 more than the Model X, considering the Cybertruck's higher weight. The next issue arises with uncertain performance in high-demand tasks. The Cybertruck, designed for heavy cargo transport, needs solid range. A 300-kilometer range is sensible, but towing loads would significantly affect this range. Equipping the CyberCell battery for heavy use does not make sense. Despite many using the Cybertruck for daily activities, Tesla should have invested more in battery technology. The production capacity is also insufficient. Producing only 650 per week, it would take about 60 years to meet the 2 million pre-orders. Despite this, production is increasing, and the wait will be shorter, but it's naive to expect everyone to receive their Cybertrucks on time. Looking ahead, the CyberCell batteries have promising potential due to high demand. With Tesla's investments, significant improvements are expected. Promising advances in Tesla batteries. Further mechanical improvements are anticipated, which will enhance the battery's performance without significant structural or chemical changes. The CyberCell battery has been enhanced by optimizing processes and mechanical design, promising future advances in battery technology, matching the 2170 batteries, and even surpassing those from Panasonic. This assertion is evidenced by comparing the 4680 battery to the CyberCell. The latter can store up to 10% more active battery material compared to the original 4680 battery, an extraordinary announcement. This means Tesla has improved its battery technology without making any chemical changes to the battery itself. However, such structural and chemical improvements are expected in the second generation of batteries, inspired by the structure of the Panasonic 2170 batteries, which incorporate a silicon and graphite anode, unlike the solely graphite anode of the CyberCell. By improving the anode and cathode, Tesla will increase the battery's energy density by at least another 10%, with potential for growth in the coming months and years, as Tesla continues refining its technology. Moreover, the main reason Tesla seeks to enhance its battery technology is its greater economic viability. With this approach, Tesla will significantly reduce its battery costs, stemming from outsourcing and acquiring ready-made batteries. Combining the high energy density of the 2170 batteries with the low production cost of the 4680 batteries, Tesla will create a more economical and superior alternative to the Panasonic battery. However, all these improvements will occur over the next few years, meaning the Cybertruck will use the current generation of Tesla's CyberCell batteries. This raises the question of whether the electric pickup will meet expectations. Indeed, it will not disappoint. The current version of the CyberCell battery will power the twin-motor model with a 300-kilometer range of the Cybertruck, providing sufficient energy. Subsequently, we await a battery innovation for the extended range and high-performance versions. Like other Tesla models, the Cybertruck will be launched with various configurations. Although this is not exactly what Elon Musk promised in 2019, it's still better than deceiving customers. It's also relevant to note that with the ongoing development of the CyberCell technology, Tesla will contribute to a significant reduction in the weight